Hello everybody, and welcome to the notes for today's lesson 8.2. So, first things first, I did want to start off with another table, just so we can see how our graphs will change when we do different things to them. To those who participated in the scavenger hunt, you already know exactly how a graph is going to change based on when we change certain things about it. To those who did not, a fantastic way to figure out what will happen is by graphing and seeing what will happen. So here I have my original graph, y equals x squared. And I filled out a table for these values. Nothing too fancy. When we graph it, it'll just give us our normal parabola. Our vertex will be at 0, 0, since we didn't really do anything to change it. And it'll slowly go up, up, and up on all sides. So there we go. These would be the 6 points that I have put in here, and you can see how the parabola, even on the other side, will probably have a point here, because it's got to be symmetric on both. That's nothing too crazy. But we also didn't really do anything crazy to our parabola. What happens if we do? What happens if we start changing some ideas about it? Well, let's explore what happens if we add or subtract a number at the very end. Now, just as a brief reminder, and I'll put this in the notes as well, all parabolas follow the same basic format. The basic format of every type of parabola is y equals ax squared plus bx plus c. We've already learned in 8.1 what adding an a is going to do to our parabola. Today we're going to learn what happens if we ignore the b and we add a c. So in this case, our parabola has an a value of 1. You can imagine there's a 1 in front of that x squared, and a c value of 3. So let's fill out the table together and see what happens. If I plug in 1 for 0, if I plug in 0 for x, I should say, that'll give us 0 squared plus 3. We know that's just going to be 3. Already we see a little bit of a change here. It went from 0, 0 to 0, 3. But let's see what else happens. If I plug in 1 squared is 1, plus 3 is 4. And we know that since 0 is where our vertex is going to be, it's going to flip over to the other side. Negative 1 squared is 1, plus 3 is also 4. If we plug in 2 for x, 2 squared is 4, plus 3 gives us 7. And if we plug in negative 2 squared is also positive 4, plus 3 gives us 7. Finally, if we plug in 3 in for x, 3 squared is 9, plus 3 is 12. You might notice a little bit of an interesting pattern between these two, but it'll be even more evident when we start graphing these points. So we'll get 2 points here on either side. We'll get 2 points here at 2, 7 and negative 2, 7. And we'll get our point up here at 12. Sorry, I had to do quick counting. There we go. This is what our new parabola is going to look like. But it doesn't look too different from the original. In fact, if I drew it out, it would just look like this. So what happened here? Did it get thinner? No, it may look like it, but it really didn't. It's going out about the same amount as our original did. Is it getting wider? No, because otherwise it would cross over these blue lines. No, all we did is we moved every point up 3. Every single point on this graph is just moved up 3. That's what your c value will do. By having a plus 3 here, this plus 3 means we're going to move our graph up 3. It means a little bit more than that, but for right now we can treat it as if we're just moving our graph up. Let's take a look at our notes and see what we can fill in. So, when c is greater than 0, this c value, the graph is a vertical translation, c units up. Translation is a word that we may not be too familiar with, but think of a translation like a slide. For instance, if I had a square here, and we wanted to slide it 2 units diagonally this way, this would be a translation 2 units diagonal. And it would end up here. A reflection is where it flips, a translation is where it slides. We won't be talking about rotations in this unit, but that's another transformation we could do. So translation is another word for slide. And the c value tells you how much up it goes, if your c value is bigger than 0. If your c value is negative, though, what do you think is going to happen? For instance, what if we had the equation y equals x squared minus 5? Can you take a prediction of what's going to happen? It's going to slide down instead of up. Instead of going up 3 like we did originally, this is telling us that we're going down 5. And that's our translation. A translation down 5. From this alone, we should be able to guess what will happen when I give you a graph with multiple pieces to it. For instance, what if I gave you something like this? 1/7 x squared plus 2. Now we've got multiple things happening at the same time. Well, let's first identify what these numbers are. This value in front of our x squared is our a value. And what did we learn from 8.1? If your a value is in between 0 and 1, it's going to be a vertical shrink. So you can imagine it as if we're taking our parabola and smushing it to be a little bit wider and more compressed. Finally, this is our c value. Well, our c value controls if it moves up or down. Since it's plus 2, that means we're moving up 2. These would be the 2 transformations that I would expect you to know for like a quiz or a test. That's actually just the majority of the unit right there. Or the majority of the section, is just picking out what the transformation does and how you know that's what it happens. So, one thing to mention is this. Notice these parabolas are still on the y-axis. This is fine. Since we're only moving the graph up and down right now, it's still going to be with your vertex on the y-axis. This is not always going to be a reality, so I hesitate to highlight this. But for this lesson, we know that the vertex is just going to be 0, wherever the parabola moved to. If it moved up 2, it'll be 0, 2. If it moved down 20, it'll be 0, negative 20. There is one more concept I want to talk about with 8.2, and that's the 0 of a function. Now, this is going to require us to sort of go back in time a little bit, to Unit 7. Remember how in Unit 7, we had problems where it was like, oh, find the roots of a problem like this, x plus 3 times x minus 7, for instance, or x minus 8. And you would have to set the whole thing equal to 0, and then you'd have to figure out what the values of x had to be to make it 0. These were the roots. And we would say if x plus 3 equals 0, x should be negative 3. If x minus 8 is 0, then x should be 8. It turns out the zeros of a function and the roots of a function are the same thing. Zeros are equal to roots. They're the same thing. So if I asked you to find the zeros of this, you would just set y equal to 0 and solve each piece. If you're given a graph and you're asked to find the zeros, that's where things get interesting. Where on, for instance, this graph, would our y values equal 0? Where would our graphs not be up or down at all? It'd be anywhere they hit the x-axis. In other words, for this dark graph, it has 2 zeros, here and here. For the lighter gray graph, it would be just 1, 0, right there. This is huge. The zeros then, and the roots, are the same as your x-intercepts. They all mean the same thing. Figure out what x should be when y is 0. To practice this, let's actually flip the page all the way to 254. Let's take a look at some of these problems here and see if we can find the zeros. All right. To find the zeros, there are 3 major ways of doing it, but only one of them is going to be really effective for our uses. We could graph and try to find the x-intercepts. We could make a table and pray that some y values end up equaling 0, but instead, I like the method that we learned in Unit 7. Let's try out problem number 5 together. To find the zeros, let's set y equal to 0, because the zeros are your x values when y is 0. So 0 equals negative x squared plus 1. Now hang on. We know how to solve for x here. We just need to get x by itself. Let's subtract 1 from both sides, giving us negative x squared equals negative 1. Well, what can we do? How do we get rid of this negative attached to our x squared? We could divide both sides by negative 1, or you can remember the little trick. To get rid of a negative, flip the sign of everything else in your problem. So let's just make it 1 equals x squared. You could have gotten the same answer by dividing both sides by negative 1. Now, to get rid of a square, do we remember the opposite of squaring something? Square rooting something. But we must be careful. When you take the square root, you are always going to end up with a positive and a negative answer. So, x, because the square root of x squared is x, equals positive and negative whatever the square root of 1 is. And what's the square root of 1? It's 1. So x is positive 1, and x equals negative 1. And we're done. The main process is to set y, or in some cases, p of x or n of x, equal to 0, and solving for x. Let's do just one more together. Let's do number 6 together, and then I'll leave you to do the rest, or the 2 others by yourself and check your answers. To find the zeros, we set y equal to 0. So 0 equals negative 4x squared plus 16. Let's start getting x by itself. We can subtract 16 from both sides, giving us negative 16, equals negative 4x squared. How do we get rid of the negative 4 attached to the x squared? Well, we have to divide it out. So let's do both sides divided by negative 4, giving you 4 equals x squared. Well, how do we get rid of a square? We do the opposite. We square root. But when we square root a number, we're going to end up with a positive and a negative answer. So, the square root of x squared is just x, so we know that's going to be part of our answer. And what's the square root of 4? It's 2. So our answers are positive 2 and negative 2. Those are your zeros. Pause the video here and try out problems 7 and 8 on your own. Did you get these as your answers? I do want to mention, number 8 is a little bit trickier. As you go through the problem, you'll eventually end up with something that looks like this. 1/9 equals x squared. Be very careful when you're square rooting this. We know we're going to square root both sides and get a positive and negative answer, but the square root of 1/9 is a little tricky. Instead of doing the square root of 1/9, try doing it like this. Split up your square root across the top and bottom. The square root of 1/9 is the same as the square root of 1 divided by the square root of 9. We know the square root of 1 is 1, and the square root of 9 is 3. So that'll give you positive and negative 1/3 as your answers. Thank you so much, everybody. I hope you have a fantastic rest of your day.